Hey everyone, I'm Noa Kind, and today I'm going to talk about data and machine learning product management. So before we start, I wanted to begin with 3 things you should know about me. 1 is that I'm Tofu's mom. You can see him here in the photo. 2 is that tomorrow is my birthday. I'm not going to tell you how old I am. And 3 is that I'm a data product manager at Monday.com. So Monday has an amazing group called BigBrain that's in charge of the data of the entire company, starting from data collection all the way to providing actionable insights. By the way, my amazing team is here today. Raise your hands. And they'll join me afterwards to the office hours. So if you have any questions, feel free to stop by afterwards. Before I jump in, I wanted to share with you why I asked to speak in this conference. So maybe you've heard this stat before. 85% of all AI projects fail. Now, this is not just a provocative statement. This is a conclusion of a research done by Gartner, like one of the leading research companies in the world. And the question is, why does it happen? What makes all those projects fail? So obviously, there could be many reasons for that. But I'm going to talk about one root cause I often find, which is the lack of product mindset. Companies often put so much technical and mathematical effort on machine learning projects and don't put enough attention on looking at the team, at them as products that require a product management mindset. And so this is what I intend to do in the next 40 minutes or so, to convince you guys how important it is to look at your work from the product management perspective. Now, just to be clear, hiring a full data product manager is definitely not the only way to go. I'm talking about product principles. It can be adopted by anyone on the team, preferably all of them. Let's start with defining what data products are. So generally speaking, there are 3 types of data products. In some cases, the algorithm is the product, the core value of it. Recified is a good example for that. The product is the model's decision, fraud or not fraud. The second type is what I call here product boost, where the model is one of the key features of the product, like Spotify, where the core value of the product is the music streaming, but one of their main features is their personal music recommendations model. And the third kind is internal, where the algorithm is built for internal use, like BI, product analytics. And I put my group, Monday's BigBrain, in the middle because we do both. We build the tools for internal analytics, and we also work on models for the product itself. My point is that those are all products, not only the tool or the dashboard or wherever it's reflected, or wherever your algorithms are reflected, sorry. The actual model, the metric, the SQL that builds a report, those are all products and should be treated as such. Trust me, I'm a product manager. So by now, I'm sure you're all convinced and eager to adopt this product mindset. But what does it mean? What are those product principles? If I had to summarize this entire talk into one bottom line, it would be this: product market fit. This is Jessica Livingstone. She's the founder of Y Combinator, and that's considered the best startup in the accelerator in the world, probably. And she coined their motto, which is make something people want. If you create something that no one uses, nothing else you do is going to matter. But once you have it, everything becomes easier. Raising capital, growth, sales, everything. And this is a really good definition of product market fit. This match between your product and what the users really want. This principle applies to all of the data products I mentioned earlier. Make a product people want, make a feature people want, or make a tool your colleagues want. Okay, you get it. Product market fit is important. But how do you get there? This is a book called The Lean Startup by Eric Ries. It's basically like the Bible of product managers. It provides clear steps on how to ensure you're building something people want. Simply put, those are the steps. You build a product, you measure its success, you learn what works and what doesn't work, and iterate. Okay, so now you're probably thinking, this is nice, but what does this have to do with me? Or in our case, with machine learning? Sorry, couldn't help it. This pun practically wrote itself. Well, I'm glad you asked. Let's break down this build, measure, learn thing into more concrete steps and see exactly why it's super relevant to the success of our projects. To make things a bit more interesting, I'm going to share a few painful mistakes that led to failed projects. Not all of those mistakes were done by me, although I definitely had my shares of failures. And I'm going to share some stories from other companies as well. I won't mention any names, so don't worry about from Checkpoint, your job is secured. Let's dive in. So the first step is know your business land. So I want to share the first failure story. A few years ago, one of the fraud prevention companies signed a contract with one of the biggest flight booking sites. The deal was super important and really helped the company to break into the international market. But when the data started flowing in, the model showed around 70% fraud rate. What happened is that one of the largest weighted features was the difference between the country where the transaction was made and the country where the credit card was issued. Now, for most e-commerce sites, that makes sense. If someone from the US uses an Israeli credit card, this can be suspicious. But for a flight booking website, where many people book flights during their travels, this is common. The company had to work around the clock to build a separate model that fits the flight booking site use case. So if you're working on a model, you really need to know the relevant business world. Without this deep knowledge, the model can go to the completely wrong direction. You need to know which data points to look at, what a reasonable weight for the features, and to be able to tell if the results make sense. Now, this can be particularly hard for data scientists that often work with different teams in different areas. My best advice is to connect with the main experts on the team and share the process of building the model with them to make sure that what you build fits the problem you're trying to solve. The second step is to know your users. So I want to share another story. I was talking to this product manager in the health tech industry that built an algorithm for anomaly detection in brain scans. The model showed great results and it was implemented in a few leading hospitals in the US. Everything looked amazing, but when she flew into those hospitals and talked to the doctors, she found out that they're not using it at all. So what happened is that the model was designed to be very sensitive, and so it also had a high rate of false positive. For the health tech industry, this sounds like the right approach because you don't want to take risks with people's life, right? Image safek and safek. But after the second or third time where the pager woke those doctors up in the middle of the night for a false positive result, they turned it off and got back to their old habits, where the intern looked at the scans and called the doctor only if they found something. So it's crucial that we deeply understand our users and their pains to make sure that we identify the right problems before trying to solve them. The third step is to formulate an hypothesis. In this step, we choose a solution that we think will solve the problem we focus on. Now, this is particularly tricky in our case because the hype around machine learning created a lot of pressure for many companies to build models only for the sake of being called a machine learning company and not necessarily because it's the best fit for their problem. Now, don't get me wrong. There are many use cases where machine learning made an amazing revolution, like in the health tech industry. But in some cases, it's not the best fit. If you're an e-commerce website and your users don't complete the sign-up process, then building a person recommendation model won't increase your sales. Here's a template for a well-phrased hypothesis. We believe that if X, then Y, because Z. For example, let's say that we're Spotify 10 years ago. So the hypothesis was something like that. We believe that if we make good personal music recommendations, our users will spend more time on the app because what they want is to find new music that they like. So formulate an hypothesis to get confidence that you choose the right solution. The next step is to build an MVP, a minimal viable product. So in Eric Ries's book, The Lean Startup, he talks about creating a minimal viable product. This is basically like a POC, proof of concept, a lighter effort version of your model that helps you validate the impact before investing a lot of time in building it. One common misconception I often find is that you can't do an MVP for machine learning models since it's very complex to create, even a first version of it. Well, I would argue the opposite, precisely because building a model is so expensive and data science resources are so limited. You need to be extra sure that the model you're about to build will be worth the effort. And to put this into practice, I'll give 2 examples for MVP that fits data and machine learning products. So the first method is if this then that function, a static, simple logic with a few conditions. If you use that, I will recommend to do some data analysis work in order to choose the right conditions for your use case. Let's give an example. Let's say that you sell shoes online and you want to increase sales by suggesting the users shoes they may like. Before building complex model for personal recommendations, why don't you do that? For each category the user views, offer them the most popular or sold shoe in the category. It's not going to be super accurate, but it will definitely give you a signal on whether or not you're in the right direction. Now, this brings up the question. If the feature does not succeed, how do you know if it's because the users don't want this feature at all or because the results of the function or the model you build are not good enough? This is definitely a really great challenge, but there are methods to separate the impact of the feature and the impact of the model itself. This is a huge separate topic, so I won't get into this now, but feel free to reach out and I can share some ideas. Okay, so another method for an MVP is to use an open source model that fits your use case. There are many open source projects, so you need to make sure that you choose a high quality one. But here are 2 good examples. One is Profit by Facebook. This is an algorithm for building time series forecasting model, and it can apply to many use cases like forecasting revenue, sales, website visits, etc. And the second one is Bird by Google. This is one of the most popular NLP models, and it can do many tasks like test classification, summarization, semantic similarity, etc. Definitely worth checking before building your own model. Okay, so the bottom line here is that build an MVP to validate your hypothesis before investing a lot of resources and time in building it. The next step is to define your KPIs, key performance indicator. So the definition of success of your project is not subjective. It should be easily measured and reflected. For that, we use KPIs. Now, when building a model, there's often a focus on success metrics for the accuracy of the model, recall, precision. Those are all important, of course. But in addition to that, you also need to define and measure the business success of the model. So to give an example, if you go back to the story of the health tech company I mentioned before, they measured only the accuracy of the model. That was great, but not the number of doctors that actually used their product. That was low. Once they gave more attention to that aspect and focused on adoption, they were able to grow. What they ended up doing is they created an escalation mechanism. If the anomaly score was not very high, the alert was sent to the intern first and only then to the doctor. So define your business KPIs to make sure you're looking at the impact you're trying to make. The next step is test and measure. Okay, so let's say that you launch your MVP and sales went up in 20%. How do you know if your model is what moved the needle? How do you pinpoint the impact of your product and separate it from the noise of other factors? Well, this is where testing kicks in. I don't mean testing the accuracy of the model, which is also important, of course, but to test the impact of your model on the business KPIs we've set earlier. The best practice is A/B testing, where only some of the users get a version of the product with your MVP. Then you can measure your KPIs and compare them against the group that didn't get this version. That enables you to get a clear indication of the model's impact. So test your MVP and measure it using your KPIs in order to pinpoint the impact of it. Okay, so this is the last step: learn, build, or iterate. At this point, you have a lot of information that can help you make the right decision. Build your model or go back to square one and try again. In some cases, you'll have an amazing success and full confidence to build your model. In some cases, you'll fail epically and need to start everything from scratch. But in most cases, you'll probably find out that you have a good direction, but learned a ton about what the users really want, so you can turn them into action items and reach product market fit and make something people want. So those are all the steps. Okay, so just one more part. I know I said that other products are just like any other products, but obviously I lied because we all know that us data people are special snowflakes. So I wanted to add more principles that are unique to data and machine learning products. So I'm pretty sure that you came across stakeholders that call you from data science projects because you don't understand how it works. It can be your colleagues, your management, your customers, and in some cases, all of them. And it's up to us to demystify the black box of machine learning in order to get resources or to get a potential customers to buy a product or convince our colleagues to use the models in their domains. Now, we're clearly not going to walk them through the mathematics of the model. What you need to do is to translate data science into English and make it accessible to our stakeholders so they can feel comfortable with machine learning and understand its value. If this is something that you feel helpful, I added in the speaker notes a few links to videos that do just that, so feel free to use them. Okay, but in order to get trust in your model, it's not enough to explain the general concept of machine learning. You also need to explain the model itself, how it works, what feature it's built on. And if the model showed a sharp change, you need to be able to explain why it happens and what made this change. There are many different ways to do that, like R and Python libraries, and a few companies that offer model explainability as a service, and you can find them all online. Just before we finish, I wanted to share a Monday use case and how we apply those principles. So this is my work, a feature that shows you all of your tasks in one place. One of its key features is the ability to hide tasks that are done, because you want to easily see what's left for you to do. Now, Monday is a super complex platform. Usually it's a good thing, but it also means that there are countless of ways for users to flag items as done, as you can see here. It's difficult to automatically identify how each user flags their own done items. Well, how do we know that this is a real pain? It was clearly reflected in many user interviews, angry support tickets, and even tweets. So we call machine learning to the rescue. But before we jumped into building a complex model, we built an MVP, where we actually used both of the methods I mentioned earlier. We use an open source NLP model to find words with close proximity to the word done. And we also took the top labels that Monday users define as done and used both of those lists to expand the automatic identification of done labels. In order to pinpoint the effect of this change, we looked at this volume of support tickets per user that were complaining about wrong identification of done, and found that it dropped by 75%. So we've learned that this is a good solution for our problem, and it's worth investigating more time and effort into this area. Okay, so let's recap. Adopt the product mindset, specifically the goal of finding product market fit and make something people want by applying the build, measure, learn method. And we also have an extra responsibility to explain data science in order to make it more accessible. Okay, that's it for today. If you have any questions or anything you want to discuss, please reach out. My office hours is now, and also here's my email address. Thank you very much. I really hope you find this talk valuable.